like, but we are very good in sticking to the rules. So we may not like it, we may be grumpy, but we like. So I spent a number of years in racing, where I learned one important thing that you are doing over here. The race is on Sunday. It doesn't matter what happens. Some people say the show must go on. Pretty much that is the thing. So you need to be there on Sunday. Withdraw or not being there or thinking, oh, I'm not good enough is not acceptable. So you do your job and you are there. And all these helped me in moving through highly regulated environments, like cars. The car needs to be launched on that day, and it has to fulfill all the safety criteria and all the durability tests. Not getting on that day means a massive loss for your business. The business is giving you, that is giving you some cash. Same is for the place where I'm at the moment. We need to be there when we committed to our customers to deliver the power units. So if they need to have a test flight or they need to have an activity, our product needs to be with them, because otherwise we'll disrupt a lot of other things that comes together. So that thing of not being late, that doing everything right, everything at the best that we can do, not cutting corner, being incredibly tough with our integrity, is something that it came from my beginning in the racing and is still with me, and you can take it across. You may or may not have done other competition with your university. The design challenge is possibly or probably one of the first time where you put together cross-functional skills, some people management, managing BOM, which is managing cost, to deliver a project. In most of your other subjects, you analyze only one of those. So you need to deliver a project, you need to do a product. Putting together all of these in time with the cost target is probably with a team of people you may have not been working with. So get you in very, very short time all the skills that you will develop in future in your career. So it's very interesting to me to see students competing. Only one will win. That is the nature of the competition. But please enjoy and take them and make the most and meet people and talk to them during this event. Engineers are here to solve the problems and to improve our life. But what did we learn in the last years, and how we can change the future with our stuff? One of the message and why I'm so pedantic with you when I review your devices about the execution is, if you do it right in CAD, highly likely you waste less energy and less resources when you're doing your prototype. So learn to do a good design, a good solid design, and focus in the execution on the area that you cannot design. There are things that you cannot really design, or they will be too time-consuming to design, so then you focus those as a risk. I don't know what is the coefficient of friction of the wheels, but I needed to calculate which motor I need. Let's start with an assumption and focus one of your tests to verify if the coefficient of friction is right or wrong, so that then your load may come together. I don't know what is the mass of my device, so how much will my chassis deflect? Well, I start with an assumption, and then I will mature everything. When I finish my design, first I will check my CAD, what is the mass of my CAD, and then I will build and verify if my actual vehicle has exactly the same mass. So try to focus on what you cannot design, and focus your time and your execution and the use of energy and resources only to fix the problems that you cannot design out. That will help us being faster in the future, and as well use less energy, less resources. Now from university and then into the work environment to really contribute to our planet to make it better. A little bit of things that I'm hoping that you have already seen at university, but there are a few things that in the design challenge you will explore. Maybe you didn't thought about that one, so I thought it was nice to do some numbers. So the design challenge is a project with some requirements. You pass from the verification, which is read the regulation and check, yes, with my concept I could do what the regulation is doing there. Then you do the validation, so you actually mature your CAD, and every time you go through it, you say, right, yes, my device still do the job in the 2 minutes, or can go from A to B and coming back to A. And then you build and you confirm that your product is accurate. Then there are a couple of things where most of the times students don't get the exposure, so which is the real world, the world of tolerance. So one is the durability. Your device needs to do an activity, so bounce against the wall. It has to bounce against the wall at least 3 times in the heat and 3 times for the final if you get there. So it has to do 6 cycles. Then you need to do all your testing that you want to do. Say that you test another 20 runs. Eventually, with the same device, you go to the national. So let's call it that other 5 a test, just to be safe, and then 6 when you're in the final. So the minimum that your vehicle needs to withstand is, call it 30 to 35 heat against the wall. It has to withstand those. If it falls apart halfway through, it's not durable enough. And the other thing is where it becomes a little bit more difficult is the robustness. The best product is the one that could be used by any operator on any surface, in any environment, and still do exactly the same job. So if your vehicle works only on that surface because that coefficient of friction is perfect, and only with Joe operating it, and when James operates it, it doesn't work, then it's not a robust product. So think about tolerances. All your wheels are going to be slightly different. All your rubbers are going to be slightly different. Imagine to put all of this together and still do the job and still get to the end point. That is one of the little things that you will learn, unfortunately, probably the hard way with the design challenge, but is a direct transposition of what you will find in life. And for me, thank you very much for coming, and let's enjoy the design challenge.
Thank you, David. That was a great talk. I would like also to call now our Professor Simon Philbin, Interim Dean of the School of Engineering, to give the formal welcome to LSBU.
Thank you, Elisa. Well, good morning, everyone, and I'd like to welcome everybody to London South Bank University. And yes, my name is Simon Philbin. I'm Professor and Interim Dean of the School of Engineering, and delighted that you're competing here in the second day of the competitions. And of course, this is the IMechE Design Challenge, the GLR, the Advanced Finals. Now, I must admit, I'm not a design engineer myself. Originally, I did chemistry and then moved into different areas of engineering. But of course, we know that design is very important, and we will all be acutely aware of this. Design is needed to address many problems within society that many of us face. Tackling difficult problems, intractable problems where there's complexity attached to them. It may be a case of improving the user experience, which is a key requirement for design. It may be generating solutions which are more efficient, more effective, more economical, or even more ethical. There are a range of different reasons for having effective design, but also, of course, it's a way of harnessing and channeling creativity. And so engineering structures and systems and processes are all important, but it's having that ability then to take that idea forward, channel that creativity. And indeed, there are many opportunities for design to be applied, especially in the world that we live in. If we think about the big grand challenges, the need to move towards net zero targets, to implement renewable energy technologies, the United Nations SDGs, the Sustainable Development Goals. And then also, the challenges around digital transformation. And people say that we're in the midst of a fourth industrial revolution, Industry 4.0. So many challenges and opportunities for engineers to work on design and design initiatives. So I'd like to take this opportunity as well to thank all of the organisers involved in this event, Elisa, Puccinelli, and colleagues from London South Bank University helping out over the last 2 days. I'd like to thank our head judge, David Migliarini. Thank you for the introduction you gave as well, and also representatives from the Institute of Mechanical Engineers. But finally, I'd like to thank you all for actually stepping up and coming along today for this competition. And finally, good luck to all of you. I hope you have a really good day.
Thank you, Simon. Okay, just a bit initial notes before we start. I'm starting talking how we're going to run the competition today. Earlier on, we had a fire drill, yeah, but in case you hear a fire alarm, the way to evacuate is just going straight on those corridors here, and then security is going to be waiting for us at the start, just to help us evacuate the building safely. Right, I would like to thank you again for those that volunteered as lane judges. Okay, Martin, again, your second day, thank you very much. Peter, my colleague, Juan, Paula, and also Bridget. Paula is there, thank you. Bridget as well, thank you very much for doing that. All right, so how are we going to run the competition today? Okay, so the first element of the competition is going to be the presentation competition. So the 3 top teams are coming here and are going to give their presentation live. And then we can have some questions from the audience about their presentation, followed by the design review. So the 3 top scoring teams for the card are going to have their card models projected here on the screen. And then this will be led by a head judge. He's going to be making comments about your card models. Just after that, we got something very exciting today, which is the ANSYS Simulation Challenge brought to us by Bridget from ANSYS. So she will announce which are the teams finalists to go to the final for this challenge. After that, we will break for lunch. And during lunch break, we are going to be, the judges are going to scrutinize your devices, okay, and say you're ready to go to compete on the lane competitions, okay? And also, doing that at the same time, you're going to be doing the peer review, so we'll give you a slip of paper, so you can go around and vote which you think is the best team, okay? After that, straight after, we will start the challenge competition. So we are going to be moving to the lanes, and we will start what we are really expecting to see your devices working on the lanes. After the judges, we are going to be doing the briefing, summing all the scorings to see who is going to go for the grand final. And on the grand final, the finalists are going to compete head-to-head. And then the judges will deliberate, and we will have finally the prize giving, okay? At the end of the day, don't forget, there will be some refreshments and snacks, beer and wine for you to celebrate at the end, okay? All right, so let's start with the presentation. I would like to call here the first team to present, which will be, just one moment, UCL C. Can you please come and present for us? Can we have a round of applause for them?
All right. Hi, everyone. We're Team UCL C, an extracurricular team of second-year students competing in the advanced category of the 2024 IMechE Design Challenge. So, our project involves in building a repeatable device simulating an autonomous vehicle transporting goods. As shown in the video here, our starting point is set at the first target, with the second target being set 1.4 to 4 meters ahead. The vehicle must then move forwards, go past the second target, touch the wall, reverse, and return to the first target, staying there for about 5 to 10 seconds. It must then advance towards and stop at the second target, all within a 2-minute time frame.
In our mechanical design process, we first focus on defining the robot's dimension and wheel geometry. By modeling the turning radius versus wheelbase to track width ratio, we determined that maximizing the length to the competition regulation was crucial. We then adjusted the width through iterative physical prototyping until resulting in a 395 by 350 millimeter configuration. Additionally, we ran spring and friction calculations to reduce tire slip, leading to the incorporation of a 3D printed spring to minimize collision impulse, as well as nitrile rubber O-rings for tire grip. The wheels were planned to have accurate laser-cut acrylic inners sandwiched by weighty water-jet cut steel outers for precise vehicular performance. We wanted to do water-jet steel cutting because it provides steel cheap components with no additional IMechE manufacturing costs. However, since our university workshop's water-jet cutter broke down and it was not repaired in time, today we will be competing with all acrylic wheels. The wheels are connected by a flange coupler to a 6mm stainless steel shaft, which proved to exhibit minimal deflection after beam bending calculations.
We then conducted torque calculations, periods of acceleration as well as constant speed were looked at, whereby approximately 0.1 Newton meters of torque was required by the motor. This also ensured no traction loss. We then chose a stepper motor. This provided more accurate incremental movements as well as the torque provided by the motor sufficient for the amount required by the motor to propel the vehicle. For our driver, we chose one that would allow for a quarter micro step-in. Again, this increased the resolution and so was allowed for more accurate rotation as well. For the sensor, we opted for an infrared sensor. This provided a more consistent and discrete response to the target's back boundary, as opposed to the color sensor. By the side, you can actually see the serial outputs for both components. For the battery drainage calculations, we assumed the stepper motor coils drew around 900 milliamps of current, and with our battery capacity being around 550 milliamp hours, this meant around 18 complete runs could be conducted without actually having to swap in the batteries. And for our PCB, we decided to opt for a custom PCB design. This greatly reduced the amount of wires used, as well as actually allowed better signal reliability because fewer connections were actually lost as well.
Our code implements a speed ramp technique to ensure smooth velocity profile and minimize motor wear. As the vehicle approaches the wall's minimum distance from the second target, the speed gradually reduces in order to minimize the impulse at the wall. The speed has been selected suitably such that the vehicle completes its run in just under 2 minutes for the most extreme case. The bullseye location is determined based off 2 observations of the target boundary. The IR sensor identifies the foremost and rearmost points of the target on consecutive approaches, and then the average of that value of those 2 locations determines the bullseye location. If the vehicle approaches at a horizontal offset, this method prevents the additional vertical misalignment that would be caused had the vehicle just traversed the radius length past the foremost point. Also, the averaging technique cancels out the systematic errors in perceived position due to sensor lag and mitigates the effects of sensor noise.
As per IMechE regulations, the budget was limited to under £80. By keeping track of all incurred costs, total expenses, excluding items under 20p, the IMechE bill of materials cost reached 75.01, with the total cost being at 81.40. The excess percentage of the total cost was at 8.53%, which is less than the maximum of 10%, satisfying the rules. We first allocated budget to crucial components, such as the motor, and then took full use of the remaining budget by implementing additional features, such as a 7-second display for debugging and voltmeters for checking battery charge, which enhances the user interface. As for future improvements, we're looking to introduce an adaptive speed feature, which allows the vehicle to complete its run in just under 2 minutes in any case, to reduce the total path deviation. This will be achieved by adjusting speed depending on remaining time, distance to the wall, and distance to the second target. One issue we can also address is a slight horizontal misalignment present during testing. Therefore, we also plan to implement a lead screw gantry system that will horizontally move the data pointer and IR sensor, improving robustness. We plan to make budget for this by reducing the chassis dimensions and removing the laser pointer assembly, as minor vehicle misalignment would not matter anymore.
Just a little technical problem here.
Currently, a device satisfies both cost and runtime constraints while consistently scoring near maximum points. Thank you. Any questions?
Your design shows a gap or a specific left void in the regulations. So we don't specify that the datum pointer needs to be fixed to the frame. And you're probably the first team that discovered that providing the datum point is there and is always attached to the frame, it fulfills the regulation. So clearly you read the regulation and you find a product that fulfills them and could deliver the job. Budget is on budget, well done. A couple of comments. I would have liked more in the presentation to introduce the challenge. So you jumped to the vehicle is doing this. So there was no why at the beginning. And the other thing is that I understand where you focused, but it was not clear how you got to the point of finalizing your design. So there are elements of why you choose rear-wheel drive instead of front-wheel drive, why you choose to position the battery there, why you choose a square base and not rectangular. So there was no evidence of you doing the brainstorming to analyze and challenge ideas and come out with a scoring matrix over there. Have you done anything like that?
Now. So I think one of your first points was why we chose to do a front-wheel drive instead of a rear-wheel drive. That's because when we're positioning the vehicle, we want to have the datum pointer on the white dot, and then we want to pivot it around that white dot to align it perfectly so that it's collinear with the second target. We're able to do that while pivoting it around the back wheels, but that would have caused an issue if we had rear-wheel drive. Yeah.
Additionally, we like to point out that at first we made like a minimal viable product, which was just like a motor, wheels, and then we tested how we shifted the weight distribution on purpose. We tried rear-wheel drive for front-wheel drive, see how it affected, and we didn't really see much difference. And that's why we ended up with the configuration right now after physical prototyping.
I just wondered if you could comment on your design methodology that you used. You mentioned MVP, for example. I mean, what were the key stages that you went through?
So first we did calculation to spec a motor, batteries, so on, the crucial components, electric components, and then we made a MVP, as we said. From there, we saw what parameters really affected performance. So was it wheel diameter, was it the wheelbase length, so on. And from there, we kind of narrowed it down, our design. And then finally, we added additional components to fulfill the remaining budget that complements user interface, such as the display, checking battery capacity, and so on.
Okay, thank you.
Thank you. That was a very good presentation. You all had something to contribute, but an important part of a challenge like this is working on a project as a team. So could you describe how you work together as a team and how you divided responsibilities, and if any of you had any kind of leadership and organizing roles?
Yeah, so of course, in teamwork like this, we had to distribute the workload. So there were areas such as working on the electrical aspect of the vehicle, areas working on the mechanical design aspect of the vehicle. Then you also had the calculations, as you've seen there, for example, the torque required to spec the motor, the battery, for example. I'm looking at, for example, how much current that motor drew to then decide what batteries to use to be able to power the vehicle. And then you also had the other aspects, creating the bill of materials as well. That's important as well, to be able to see if we actually meet the requirements. So yeah, in terms of the tasks, that's how we separated it out. We also did assign a team leader as well to be able to actually separate out the tasks, but as well, it's always good to have a team leader to be able to see, where the team is, and to always keep on constant communication. So that's something we did consider, something that we did implement as well, to be able to provide a working vehicle, as well as have all the required documents and documents and so forth to be able to be prepared for the competition. So yeah, that was carried out.
Thank you very much, UCL C. Great presentation, great work. Thank you. Can I have here UCL D, please?
Okay, cool. Hi, we're Team UCL D, and this is how we designed and manufactured our repeatable vehicle. So as you all know, the competition states that we have to start at one target, drive towards the wall, reverse once we hit that wall to the first target again, and then drive forward to the second target. The requirements also state we need to stay within an £80 budget. We cannot change anything once we put our vehicle down in the track, and we have to fit within a 400 by 400 by 400 millimeter dimension. To tackle these problems, we first prototyped with a rear-wheel drive. We realized, and a pulley system. We realized this could cause a lot of slip and possibly not enough power to the wheels, as we have manufactured our own steel wheels to ensure a stable and linear drive. We then, in our second prototype, we had a gear system with a full-wheel drive to allow the car to go forward and backwards safely without any misalignment. Our final design consisted of two spoilers, we call it, to cover the gears and the electronics, and to also have enough space to fit everything on the board. We also, as you can see in the engineering drawings, stay within our dimension constraints of 400 by 400 by 400 millimeters.
We implemented a gear ratio of 2:1 to ensure that the vehicle travels slowly with an increased torque. The gears are locked into place on the shaft using grub screws to prevent the gears from slipping and misaligning. They are manufactured with 3D printing with 0.2 millimeter tolerance and 100% infill. We decided to 3D print as such off-the-shelf gears will not fit onto the shaft. We also implemented chevron teeth pattern to prevent axial slip. Our four wheels have 75 millimeter diameters. They're made of steel and are fitted onto 8 millimeter diameter aluminium shafts. They are thick and heavy, which ensure that the vehicle travels in a straight line, and are manufactured using CNC lathes. The rear and front wheels are also tightly secured onto the shaft with nuts on either side. The front and rear spoilers both include flange bearings to reduce friction on the axles. The LCD on top of the front spoiler keeps track of the distance and the color detected by the color sensor, and the rear spoiler supports the breadboard and rocker switch. The front spoiler weighs 67 grams, while the rear spoiler weighs 144 grams. We determined the current draw from each of the electrical components and determined that a 1 amp fuse was sufficient to ensure that the circuit is safely used. From the graph, we discovered that a single 1.5 volt AA battery is expected to last 3 hours.
We also created a wiring diagram to keep track of how all our components will be connected. It also allows our other team members to work on the electronics, so any wrong or faulty connections can be avoided. It also allows us to test the device over several iterations, and it allows us to edit the wiring if needed. For our reverse mechanism, we're using an ultrasonic sensor attached to the front of the vehicle. This sensor detects the distance from the wall and reduces impact at 15 centimeters from the wall, and this is done using PWM control with a duty cycle of 512, which reduces the speed by 50%. An SPDT switch is used to reverse the device. These are conventionally held down to reverse, but we've programmed it to act like a DPDT. At this point, the Raspberry Pi would record the number of forward revolutions and then do the same going backwards, which ensures we are as close as possible to hitting bullseye. To stop at the second target, we're using a color sensor that activates after the 5-second pause. This sensor detects blue and stops the vehicle after a time delay. We figured out this time delay just by completing tests, so we always hopped in between the testing and design stages during the iteration process. For our programming, we completed all the programming using CircuitPython. We used the async IO library, which allows us to use which allows us to create multitasking programs. This allows this system section to occur as the number of revolutions is counted, and a section of our code shows how we implement the 5-second pause and stop and start the motors.
So we then set about creating an analytical solution on Excel, and a short snippet is shown on the slide. To increase the reliability and accuracy, we decided to include drag and rolling resistance into our calculations. And this led to the following graphs from our Excel. So theoretically, the car, starting from 4 meters, a maximum 4 meters distance, will take approximately 13.5 seconds to complete the entire challenge. And then finally, our final weight and cost. So the total weight of the vehicle is approximately 2 kilograms. And the most expensive components are the motor driver and the wheels. But all in all, it all comes underneath the total cost required. Thank you so much for listening today. And any questions?
Thank you, very clear presentation. So I really appreciated that you put the introduction of the presentation and you show your thought process. I have a couple of questions here. So one, you had a good idea. Having light wheels is okay for racing. In these, having heavy wheels will help you to keep straight. So hopefully all the other colleagues and somebody else will pick up on this thought that you had. But what about the friction? Because steel wheel on a man-made board may not have a great friction over there. So that is one of the things that sometimes create a little bit of uncertainty. Then in one of your circuits, you show that you had 2 electric motors, but on the product I see only 1. So there is a circuit diagram where there were 2 motors, and now there is are you 4-wheel drive with 2 motors?
Yeah, so as you can see, so there's a motor attached to the rear axle and a motor to the front axle as well, so it's 4-wheel drive system.
Okay, so it would have been nicer to see your journey in rear-wheel drive, front-wheel drive, all-wheel drive, and how you score the different ideas before actually going on CAD. And then one engineering bit. So your budget got very, very close to the edge. So you got 75 plus for the IMechE budget, where the top is 80 quid. And you left in your device a display that is used only for your testing and development purposes. Now, something which is left in a product that is not needed to fulfill the mission may be a point of failure. In your case, the failure could have been running over budget, or the display start to be funny while you're using the device and not allowing the device to do the mission. It would have been better to think about removing the display when you finish all your development, because it's not really needed there. And that's it so for me. So just in the future, think about the friction in your content. It may be useful.
Thank you from me as well. You mentioned about making this choice between being able to buy a standard part or manufacture it yourself. Could you just explore a little bit more about your decision there? Because obviously, standard part perhaps may more certainty over the performance and dimensions. Making it yourself, some uncertainty. Why couldn't you start with, well, I'll have one of those and design to the standard product?
So one of the, to address your point, especially with the gears, we could have easily bought those as well. The reason we didn't is because, again, budget, and also the way our motor shaft is, the shape of it, we wanted to design our own gears. And although off-the-shelf components might be a good choice, we would have had to add shaft extensions, which we didn't really want to do. We didn't really have the space for it either. So we thought it would be a good idea to manufacture our gears, and we've run so many tests on them. That was the whole point of just checking if if manufacturing is a good way to go. So we ran a lot of tests, a lot of iterations, and yeah, we were able to finalize our choice that this is a really cheap method and a reliable method of us being able to complete the challenge without having to rely on industry standard parts as well.
Okay, thank you.
Thank you. On one of your slides, you give a calculation of the time taken for your device to traverse 4 meters. Can you forward to that? Okay. Did you actually do any testing to validate and benchmark this this time?
Yeah. So these calculations that we only done were for going straight, and not we didn't have the time to actually simulate vehicle deceleration. So what we did was, yeah, we did test it in real time as well. I think there was a video there that showed us actually completing the challenge as well. And I think they were roughly similar. I think we got 11 seconds doing a normal test, and from the theory side of things, we got 13.5 seconds. So it was roughly similar. I would assume that the differences were because obviously there are a lot of losses, maybe slip as well. And again, our Excel model took into account a lot of assumptions because we didn't necessarily know our final vehicle mass or our final gear ratio. We didn't really, we had to assume a lot of things with this Excel model. And then once we did finally manufacture our vehicle, we were able to finalize and test. And yeah, we were quite close with our simulations as well.
Hello. I wanted to ask what development platform are you using? What development board are you using in your design? What development board? What microcontroller?
Oh, we're using a Raspberry Pi Pico.
Yeah, because in the CAD design, I saw the CAD was for the Raspberry Pico W, so yeah. It doesn't match. Are you using the Pico W or the Pico?
We're using just the Pico, yeah.
The Pico, oh, yeah.
Yeah.
In the CAD you have the Pico W, so I thought that maybe you were using the Pico W, but if you're not using wireless functionalities, then you don't need it.
Okay, I'll have to double check. I'm not entirely sure which exactly we are using, but I'm pretty sure it's a Pico.
Okay.
Yeah. Right.
Thank you, UCL. Thank you. All right, I would like to invite now to present for us Kingston A Advanced. Very brave.
Hi. I can't promise that my presentation will be as beautiful as the one that the two UCL teams did, but anyway, this is our repeatable vehicle design. Our CAD is quite simple. It's just a 3-wheel design, which was chosen for the utility of motor differential, where we could implement a code function that will realign the device if needed, if more accuracy is needed to get on the bullseye. So our design is made up of 2 IR sensors, well, used to be, and I'll get into that. A micro switch in order to notice the wall when it makes contact with the wall. 2 a BYJ 48 stepper motors, and an ultrasonic sensor, and it is using the microcontroller Arduino Uno Rev 3. The IR sensors were part of our first prototype, but we ended up switching it out for 2 LDR sensors. The reason for that was that the LDR sensors, they give you a very accurate reading as to what color or what surface it is on top of. So for that, we used it to detect the outer ring of the bullseyes. So going from point A to the wall, you run the steppers at full speed, and they're needed because they have a built-in encoder which can keep track of the amount of steps that you've made for the distance from A to the wall. And it can just easily, through the Arduino IDE, coding it, and through the microcontroller, you can just input the same amount of steps in reverse to get quite accurately to the starting position. From there, what you can see This is the three-wheel design. And we have the LDRs that go through these two slots there. They have their own LEDs, so reading from the LDR should remain fairly consistent, no matter the lighting in the room, because they have their own lighting. And it is a 20 by 23 centimeter design. So this is roughly how our device works. This is with the IRs, but just imagine that it's the light-dependent resistors. They're quite close to the ground, as you can see, because that is how you're going to get the most accurate reading. And if you approach the bullseye misaligned, you could use the code in order to recognize whether one left LDR is switched, then maybe it needs to turn right, or if the right one is switched, then maybe it needs to turn left to, again, increase that accuracy. So how much does it cost? With the IRs, we ended up getting to about £77, which is really pushing it. But again, we decided to go with the LDRs, so it'll drop to about £75. And yeah, I believe that is it. So if you have any questions, or if I can expand more on the device, then feel free.
So very interesting design where you thought about steering axle actively. So very, very good, and almost like a self-driving thing. Pretty much as a comment that I made scattered in the previous team. There was no introduction of the competition. So you assume that your audience was already understanding what you are talking about. If I need to buy this product, I don't know what I'm buying or why I'm buying it. Second, again, relatively little evidence of why you got to the three-wheel in this configuration, why you got to the ball, why you got the three-wheel in another configuration, and stuff like that. Two things. You said that you rely on the stepper motor to count back.
Yeah.
You need to be incredibly sure about the friction, because if you have a slip, the stepper will count.
Yes.
But the vehicle don't move.
With the stepper motors that we have implemented, we can recognize. They do say with just the product that it's likely to miss one or two steps, but overall you're not missing out. And through testing, we've noticed that even if it does miss one or two steps, the difference is not major to get completely off the bullseye. And if you're running it at what we have now is a 5-volt power supply at 1,000 steps a second. We get fairly decent and accurate stepping count. So yeah, we ended up with the three-wheel design mainly for that differential to make it a 360-degree turning radius, because you can run one stepper backwards, one stepper forwards, and you can remain on point.
Turning radius. Yeah, we went through a lot of ideation process where we considered what was crucial for the actual competition, and we originally did start with a four-wheel design, but then we realized the turning radius was a big issue that resulted in a lot of other further ideas we had to solve. And with a differential design, obviously it can just rotate on the spot. We don't have to consider the size of the vehicle as much, and it simplifies a lot of the other design process.
The purpose of the competition is to buy a customer into your idea. So I need to see that you have evaluated their idea and why your idea is better. At the same time, they evaluated something like your one, and they declare instead that their idea is better. So the idea of showing your customer the screening process is right there. Why I need to buy your car if their car does a job exactly the same. Another thing, and that is where I'm even a little bit less, more grumpy than normal. You declared a BOM, but there was no delta between the IMechE BOM, which is the one without the 20p components, and the overall one.
We have included
both. And then you declared that you are changing the sensors. So
Yeah.
Which bomb am I looking in this presentation? Which product am I going to look afterward? What have you done? Yeah. So that is a key of the presentation and the CAD design. Show us what that you did all your engineering to tell me that you're building what is on the paper. Yeah. So what is your total budget? And
our total would be £75.
So in the IMechE one without the 20p?
Without the 20p, no, sorry, without the 20p should be 25, 75. With, sorry, yeah.
This is a bit old.
Okay, so
we have the actual BOM in the table.
It should have been here.
Yeah.
Of course. Yeah.
Hi, thank you. I only have one question, and I think I didn't get that from your presentation. Does it work?
Yeah.
Yeah, we have done testing. We haven't fully tested how reliable the vehicle is on over the actual testing for today, but we have conducted multiple tests on like variations with distances and how.
We've done it on different surfaces as well, just to see if the LDRs really make that massive of a difference, and if it can still manage to detect the bullseye. So we've given it a bit of leeway and implemented through the code just to make sure that once the black line is detected, it should stop.
Yeah, I think it would have been really good for you to include that in your presentation.
Yep. Yeah.
You were asked about the stepper motor and the slip. So my question is going to add on that. Your device has two-wheel drive, and if there is any slippage of one of the wheels, that means your device will turn slightly on one side. Even if the steppers are counting accurately and they maintain the same number of rotations left and right, if there is any imperfection, which life is full of them, on one of the wheels or contact, that means you will steer away from your straight line. How did you consider to mitigate this misalignment?
Well, do you want to answer?
Okay. The differential design, obviously, it completely eliminates the requirement of having to move in a straight line because the vehicle can just turn and reposition on the actual target. Obviously, if you're using a four-wheel design, you can't really realign when you approach the target. You would have to do some weird back up and back forwards to align the actual target. But when you're using a differential drive, the wheels can rotate counter on each side to reposition to position the data point directly on the target. And we also used, it's not explained here, but we also used a triangulation process so that the data point is always positioned correctly in proportion with the two sensors that we're using. So as long as the proportion of the vehicle with the chassis is all correct, it should be accurate every single time. There's no realignment issues.
But your solution only works if your vehicle never steers away from the perimeter of the target. So as long as you have a bit of coverage on the target, it can correct itself. But if there is any chance...
Through testing,
we never encountered these issues.
You never got too much on the side.
Yeah.
I understand. Thank you very much.
Okay.
Thank you very much, Kingston. Well done. And thank you for all the teams to present, and well done for answering the very hard questions. Yeah. Okay, so that's the end of the presentations for today. We will move on now with the design review. So can I have here team UCL D for the design review, please?
Please for my hand. Oh, that's fine. Is it touch screen? Let's try now. There we go. So, right. So I'm just showing on the screen your CAD, and this is the device that you can see. Is fairly accurate. A couple of things. That you didn't fix the batteries. You did roughly half of the wiring, so I hope that helped you in doing some bits and bobs. Things that I've seen in reality is that you could clearly see here all your devices, and you didn't thought about protecting all the electrical devices and all the other stuff. So the CAD is fairly accurate. Wiring was not there. Did you find any challenge, any interesting event?
As you can see, the wiring is a bit complicated, so I think we just did the functional ones, the ones that actually made a big difference.
For the wires, we modeled all the wires that actually drive the device. We didn't model the wires of any sensors, purely because we didn't want it to just be a complete mess. We wanted it to represent our device a bit, so we only modeled the wires that would actually drive the device forward and backwards as well.
Yeah, but as a result, the actual product, which is what we're going to use, is a little bit, not a complete mess, but is a little bit on the challenging side. So things that I understand that modeling the wire could be time-consuming and complex, but things, if you look around, you may have wires relatively close to your gears, so that could be a functional issue. You had laser cut part, and you had a 3D printed part where you could have included some wire management, eyelets, pre-holes for clipping, or all the other stuff that may have not costed anything. So one of the things that we saw yesterday, there was a team that drilled a lot of holes in the laser cut activity and just passed the wire through. So they didn't add any cost for component to manage the wires, and they actually reduced the cost of the board, because the board had a lower area.
Yeah, we did try to mitigate that by taping it to the bottom of the spoilers. So yeah, we did have the issues with the wires touching the gears, but we had tried to stick it at the bottom.
Yeah. Is the battery, so the battery is moving?
Yeah, we can.
Oh, you will strap it down. Okay, okay. Apart from that one, what was the most difficult thing? So if I look at this, you have been fairly accurate. So there are all the characteristics that you needed are here. So you have your bearings, you have everything there. So you really went, you really did a good job considering the time frame and the purpose of the thing. What was the most difficult bit that you found?
It was changing it after every iteration. So we had one initial design, and then once we tested it and we wanted to change something, we would then have to go back to the CAD and then change that. So that was the most difficult part, because we just had to keep changing the CAD back and forth.
You learn how to have effective CAD technique when you, if and when you go better. But yes, that happens as well in real life. Don't worry.
What did make it easier is we tried to add codes to almost every single part, which you can see along the side. This just helped us, you know, when you say an effective CAD technique, we didn't have to continuously go back and find that part and then put it back in. It was just always using these single parts and then just rearranging them, because the device arrangement changed. So it was just moving around bits and pieces and keeping the same parts essentially.
Okay, now given that you're all here, let's put it on the scale and see what is the weight of the device that will run. Any other question from anybody else? Thank you very much.
Yes. Okay, the next one, UCL C. If you open Fusion again, sorry for the. Yeah, is that?
Where did it go?
No, but. And then open up. So yeah, in the middle one.
Okay, so. Good. Let's have a look. It looks like your CAD is very, very accurate. I don't know if you want to stay. If you want to, thank you. If you want to stay in the center so that other people could see the difference between the CAD and the product is almost negligible. There is a little bit of wire management, but apart from that one, I cannot really see big differences. I see that both in the real product and in CAD, you try to keep all the heavy components in the center. Was it coming from the day zero? Was learning from previous design? Why you choose this good idea?
We wanted to keep the weight distribution fairly center, but one decision we made was we tried keeping the pulley in the middle, which would offset the motor. But then right now we have the motor in the middle and the pulley to the side. We thought that if we have the pulley in the middle and off to the side, it might angle the shaft a little bit, but that wasn't the case for us, so that's why we ended up with this design, where all the heavy components are located in the middle line.
Very interesting that you decided to have almost a switch bumper at the front with the 3D printed stuff. In our company, we have a 3D printer with the capability of making flexible parts. So not with rubber, so with the plastic. Thinking about a spring in 3D printing is a good thought. So you could really explore the technique. In terms of execution, how many trials, how many attempts we did with the design before breaking it or making it work or whatever?
Oh, is it turning those springs?
Yeah.
Yeah. So the reason why we went for 3D printed springs in the first place was because we can prototype so quickly. This print is about 5 to 10 minutes. So we did about 3 iterations. Oh. So that's just 15 minutes of our time. And we don't have to buy extra springs or like normal helical strings.
Oh, that's good. So you did only 3 iterations to get to the spring that you wanted. That's remarkable. Everything looks very, very in line and accurate, and you did a good job. Thank you. Shall we go on the scale and see how it looks like?
Just a disclaimer though, since our water jet cutter broke down, we couldn't put steel wheels in the BOM. It's for steel wheels. Do you remember the weight?
Yeah, for the steel wheels, it's around 2,500. But because we don't have the steel wheels, 17.
Unfortunately, we judge what we see.
Yeah, it's just a comment, so you know. Yeah, we understand.
Thank you. Now, can we please have Kingston A advanced?
Can you please go over there so that other people will see? Where is the battery?
I think this is enough.
Sorry, I was joking. Where is the battery? Here
There is way no. This is in here inside this battery pack.
So there is way.
We up a little bit and we layered it. We layered it because we had an included breadboard that I didn't include in the CAD, but I shifted everything up a little bit, slid the battery underneath.
So the thing that I see here is that there is a different content of the device compared to what you put in CAD.
Yeah.
How do we know if you're still in target for the cost or not? Because clearly you have put more stuff.
Well, no, in the BOM I have included the.
That's
I've
interesting.
included
So
the
why you did
breadboard,
CAD then? If the CAD is not helping you to align with the BOM.
Yeah.
The build, so.
It was, more, I guess, more of an artistic representation. Yeah.
Well, yeah, we are here to score your artistic representation from an engineering perspective.
Yeah.
So shall we use like a colorful hat and the oil paint out?
No, but yeah, the rest is you have the IRs at the bottom, the ultrasonic, and the steppers. Well, we've also CAD'd the wheels. Because these originally were made for servos, continuous servos, but we swapped them out for steppers, and when we made that decision, we 3D printed the wheels the same dimension as the servo wheels in order to slip on the silicone.
Okay. Could you please flip it underneath so that we have a look? So you extensively use the 3D printing, which is great, and there are a lot of windows over there. You clearly didn't thought about cable management, and your device look a little bit
crazy.
Well, it's not crazy. If you think about the robustness with the wires that deliver a function, so the stuff that you have there is for a job. If you don't think about them, they could dang around and get tangled and potentially stop you prevent you from delivering the mission. So one of the advantages that you have in using CAD is that you could think about all the stuff and think about what things could go wrong. So yeah, shall we go on the scale?
Sure.
Is there any other question? No, I think that we're okay. Thank you.
Thank you.
Thank you, Kingston. Thank you. Yes. Okay, well done again for answering the questions and presenting your card here. Not an easy task. Let's just move on with our schedule today. Sorry, just coming back here. So I would like to call Bridget Oguezi. She brought to us this amazing addition to the Design Challenge this year, which is a great opportunity for the students to put their engineering skills as well into practice. So Bridget, over to you.
Thank you, Elisa. Thank you. Thank you very much. Hello, everyone. My name's Bridget. I am part of the academic program at ANSYS. We've been involved with the Design Challenge for a couple of years here. Davide would know when I first showed up, I fell in love with just the practicality of the challenge. I'm a civil engineer. I have a degree in civil engineering. I did a bit of concrete making while I did, but nothing else really practical. And I came out of university terrified of going into work because I didn't think I could actually do anything. So I really appreciate the level of practicality and the challenges that you go through here, because that makes you ready to face work or even start your own company or build your own house. Whatever you want to do, you get those kind of skills in these kind of events. And the fact that you're starting, some of them like even the first year, fantastic. Love the whole concept. Okay, so today I have a few slides, and I'll just quickly announce who did the best in the design in the simulation challenge. But my talk is going to address academics, the teachers, and also the students. So the slides, you'll know who I'm talking to when you go through the slides. You know who it is. So the ANSYS academic program, we have a mission. We do simulation, if you don't know what ANSYS does. Structure analysis, fluid analysis, electromagnetics, optics, name it, we probably do it. Companies use us a lot, so we want to work with universities, with students, that students have this skill. We call it a superpower, We call it a superpower. I want them to have the superpower to go into industry and, just be amazing and solve problems in the most efficient way possible. And one of the things we do, of course, is work with student competitions like this. To help with that, so this is the academic part. So we understand that adding things into the curriculum, even adding things into a competition like design challenge, adding elements is a challenging thing to do. So we have a partnership plan if you're interested in adding simulation into the curriculum, but there's some challenges. We have a fund that can help. Talk to me about that. I manage that as well. So we want to help you to do this well and to help your students succeed. So currently, we've done that for like a year and a half now. We've worked with different countries all over the world, universities all over the world, to integrate simulation, to update their courses, and we're going to continue doing this. We've just finished a round of applications. We have another one going on. So every year, we're spending about £250,000 on this. So please get involved. We'd love to work with you. Okay, and also for the students, careers begin with using ANSYS. So I will highlight one particular person here, Christina, right at the end. She was in a student team, one of those car teams, became an intern at ANSYS. She was kind of sneaky. She wanted to join an F1 team, and she thought it was hard to join the F1 team directly. So she thought, I'm going to be a CFD engineer, first of all, at ANSYS. It worked. 2 years later, after working for ANSYS, Red Bull poached her. She's got her dream job now. So careers they really do help understand the skill of simulation. We're not just saying it. But aside from that, this chart says, in summary, that a significant part of design is spent figuring out what's going to work, not going to work. About 70-something% is just figuring out what will not work. That wastes time, it wastes resources, effort, frustration. But if you're using simulation, you can exponentially reduce that. That's the whole idea. Designing out the failure modes on the computer before you build the first thing. And that's the whole idea in a nutshell. And as we're moving towards a more sustainable environment, using our resources more efficiently, this is a thing that's becoming more and more important. And it does mean adding an extra layer into what you do, but then you're just being more efficient in what you do. So that was what challenged me to add this simulation layer into the competition. It's an add-on, it's not compulsory, but if you're doing it, it can make you more efficient. So this was the idea. You could do a structure analysis, a thermal analysis, a fluid analysis, and I had a little video, if you've seen this online, of what was possible to be done in this simulation challenge. And it should run, hopefully, in a few minutes. I got a colleague of mine to do this for me just to show the idea. And the beauty of the thing is that with ANSYS, of course, you can do any of these things. We've got tools to support you with all of that. Not only that, you can get the software for free if you get a partnership with us. I feel like I'm marketing myself now. No, but just the superpower and the ability to design more efficiently is what I'm really talking about here. Okay, cool. So thank you to the 2 teams that did submit on time for this. It's the first year we're doing it, so this is great. And I think my job here is just to announce who did the best in it. Now, what split the 2 teams, I will simply say, was just one thing. So you scored the same on setting up your boundary conditions and things like that. But what split was that one team optimized their design after doing the simulation. And they clearly demonstrated what they had changed and the impact that had made, which is the whole idea of doing the simulation. And I think they're smiling, or the team that knows they did what they're smiling. So just congratulations to UCL Team C. If you want to know a breakdown, I'm happy to have a chat with you afterwards about it. So that means that you get to go to the finals of this competition where you get to have a blog with answers. You get a certification. It's like the certification costs about £300, but we will provide that for free for all the students who will take it. That goes onto your CV. You take it into your career that you are certified to use answers. And that's me. Thank you very much.
Yes, you can. Thank you very much, Bridget. That was brilliant. Well done on UCL C again. Okay, so that's the end of our first part of this competition. We can have a break now. Lunch is going to be served soon. And I would say for the students, use this time as well to network with the other teams, with the academics, with our judges as well, and do the final touches of your devices to get ready for the challenge in the afternoon. Thank you very much today, and I'll be back to you soon.
Join us at London South Bank University for the making of you.
Yep. How's that?
I mean, it's wobbling all over the place.
Great. How's that? Great.
touch the wall, it reverses the switch, and we're trying to come back as close as possible to the. Oh, you see, battery is there. Try to come back as close as possible to the.
And it's all been pre-programmed to do that.
It's not programmed, it's only it's a switch.
So how does it know when to stop?
Because they calculate the frequency. So it's supposed to see. So yeah.
Okay.
And once if you stop on the black, they will score 2.
Right.
And in the middle is 10. And
And it's different
distance
distances.
Yeah. The hardest one is the long.
And this one,
We are not using this one. Yeah, we are just doing 3. And today is different because they can use programmable devices, like I'm doing.
Okay.
And they are going to have 2 targets. So they will start on this target, touch the wall, and then come back on the try to come back as close as possible.
So is the competition over?
Oh. No, the advanced will start after lunch.
What time? I might come and have a look.
You can come back at 2.
2?
2 around 2. We'll be getting ready. 2:30 more.
Yeah, okay.
That's fine. And we're live streaming. We go cameras. Yeah.
Good. Where's the audience?
Well, I was expecting lots of people that said.
Hi everyone, I'm Abdul and I'm here at the IMechE Design Challenge 2024 in the advanced division. So yesterday that was the initial design challenge. This is the advanced one, so we're on day number 2. I'm here with Philly from the Kingston team. So Philly, how are you doing?
I'm doing all right, thank you.
Excellent, excellent. So just a few questions. Essentially, after the judges' the constructive criticism you received, how do you feel going forward with this?
Well, I feel that there's a lot of room for future implementation and future work that could be done onto the repeatable vehicle. It's really quite interesting to see UCL's perspectives and all the other universities that are here, and all talking to the individual students and seeing what they, what kind of sensors they've chosen and so on and so forth. It's really, really interesting, and I think we could take it back to Kingston. Remodel and maybe rework our design, and maybe the next student after me might do better. And I think it's really it's quite an optimistic outlook for next year. Yeah.
Excellent. And now that you're here and we've had the presentations and we've sort of gone through essentially the less of the action. We're just about to go into the action of the races. How do you feel? What's the atmosphere like for you?
Well, the atmosphere is, for me at least, is quite tense because you don't know if it's going to work until you actually get up to that bullseye, hit the start button, and hopefully everything runs smoothly. I mean, this is why, as engineers, we do tests and we do multiple iterations of our designs, making sure that our sensors work well with the code and the electronics and everything that goes into it. You have to make sure that that communication between the technical side of things are consistent. And again, if you look at the other universities, yeah, they work, but you know, that's why we put in so much effort. It's to make sure that that one run that counts works as well. So
excellent, excellent. Now, my next question would essentially just be: you've worked on this for months, I believe. Is that correct?
Yeah, months. Yeah, since October. Excellent,
incredible. So that whole journey, how has that been for you personally? What kind of like development have you seen?
Well, as a fourth-year IMechE student, it's been quite hectic to keep up with, you know, the IMechE Design Challenge, obviously, because you have other priorities and other preoccupations before, and you know, it's learning something completely new, right? Because this is engineering at its finest. You do iterations, you do testing, you, yeah, you just want every single part of your device to work. Even if you don't know that much about electronics or if you don't know that much about coding, you have to find the time to get into it and really figure it out, which is quite fun. But the development, yeah, we got to where we are, and it's a working prototype. Could definitely be better, but I'm happy with where it's at, and I think it's my efforts that have paid off. Yeah.
Excellent, excellent. And have you ever been to an IMechE event before?
No, this is my first time being at an IMechE event, and I kind of like it. It's really, really nice to be here.
And just on a last question, what advice would you give to someone who perhaps would be thinking about doing this next year?
Well, value your time and split it off wisely. Know when you're going to, commit to this project, because there can be last-minute alterations where you want to change a sensor, or you want to change your motors, or you want to change whatever it could be. Make sure that you start early on and you really get into the research of it, because there's quite a lot of resources that have covered competitions like this before, and obviously UCL and they upload their like a bunch of videos of the prototypes and this and that, and it's really good to look at because you get a whole bunch of different perspectives that are quite interesting.
Excellent. It's been a pleasure interviewing you, and
All right, it's been a
good
pleasure.
luck with the races. Thank you.
Thank you so much. Thank you.
Cheers. And that's all, folks. So we will have a few more extra interviews as we go around today. So stay tuned for that. And for now, just signing off. Thank you. Okay, ladies and gentlemen, as promised, our second interview of the day, I'm here with Rashad and he's part of the UCL Team D. Rashad, how are you doing today?
Yeah, it's been good. The competition's been a bit crazy so far. We're still waiting for the actual main competition to start, and yeah, it's been fun. It's been crazy looking at other teams as well, and yeah, we've enjoyed it so far.
And so far, what's been let's say, the most exciting part of the competition? Of course, the races have not yet been done, and we all know that that's usually where the suspense is really, at, basically. But so far, you presented. How did that go, in fact?
Yeah, I think the presentation went good. We were all very well spoken. I think we kind of knew what to expect because we have that experience from being at the design challenge from last year. So I think we answered the judges' questions quite well, and yeah, I think it was very good for us. Yeah.
Excellent. And in terms of the design process, how has that been for you? Because I could see that you were very well organized. So how was that from start to end? Just give us an idea of what that was like.
Yeah, there was a lot of project management from our side. There was communication between all our team members. We distributed all the work, whether that was the BOM, the CAD. We kept in touch and we always updated everything together, which was very important. And that's what made this project a success for us. We always tried to keep everything updated together. And yeah, we're very proud of ourselves and what we've given to this competition. So we'll see later on how it goes.
Excellent. And now that you're here and you've observed the competition, how do you feel going into the races?
Look, I mean, you got to give credit where credit is due. There's a lot of talented teams that are here, and we're very happy to compete with them. We know that it's going to be tough. Like I said, we're very proud of ourselves and what we've done, and we wish everyone the best of luck. And yeah, we'll see how it goes.
Excellent. And as a final question, so you've done this for 2 years essentially. What exactly have you learned those 2 years, and what piece of advice would you say would be the most key piece of advice for someone wanting to do this?
For next year, or just?
Well, in general, for next year.
Oh, in general, yeah. I mean, these extracurricular projects are always such a good way to learn more about the practical side of engineering. Theory can only get you so far, and just by, we failed so much with this device. But just going through that iteration process and understanding the engineering processes behind everything, and it's a very good learning experience for someone that wants to understand engineering design. And yeah, we've really enjoyed it. And for anyone that wants to do it, I would say go for it. It's a very good opportunity to compete.
Excellent. And so we've seen here, I believe for one of the first times ever, there was an ANSYS challenge, and your team, as well as the other UCL team, also participated. Just a question on that: what kind of development? What was the development like of developing the skills, being able to use that software, or has it always just come naturally for you?
I don't think anything in engineering is going to come naturally. I think it takes a lot of iterating, and with ANSYS, it is something that we do have experience with our university. So we took on that challenge of modeling our gear deformation, and yeah, I think it was a good learning experience for us. We actually managed to prove why we wanted to use the gear ratio that we chose using ANSYS. And credit to the other team, they've smashed it by winning it. Everything was unbelievable from their side. So,
excellent. So a key part to take away from this was that, in general, this was an excellent learning experience for everyone involved. I guess that brings me on to my last question. I would have to say, after seeing your project and seeing everyone else's project, do you think there's anything you could have done differently?
Yeah, I think if we had just that extra bit of time, we would have maybe been able to iterate a bit more, maybe actually look into slowing down our vehicle before impact. We did have quite a few issues with that. But yeah, in terms of what we would do differently, I think the judges mentioned it as well during our presentation. We did get very close to the £80 mark. Maybe just finding alternative ways to bring that price down. I think maybe changing our chassis design to, again, bring the price down. Yeah, there's so many things that if we had a little bit of extra time, we would have tried to implement, yeah.
Excellent. Thank you so much for being interviewed.
That's all right.
It was a pleasure, and we'll see you soon, folks, as after lunch, I believe there should be some peer review / scrutineering by the judges. So stay tuned for that, folks. Thank you. Hello, everyone. So I'm here with Simon Philbit, Interim Dean for the School of Engineering. How are you doing, Simon?
Very well, thank you, Abdul. Hello, everyone. Delighted to be here today.
Thank you. So just a few questions. So how does it feel being the university that is hosting the event this year?
Well, I think it's very good, and the School of Engineering, design is a key part of engineering within the mechanical engineering and design, and I think it's excellent for LSBU to be hosting this event and also to be partnering with the Institution of Mechanical Engineers, which is a prestigious professional society for engineers.
Thank you very much. So another question. So you've seen the level of competition here. You've seen the ingenuity that students have shown on display. How does that make you feel? You know, seeing all of this in young and up and coming engineers.
I think it's really impressive to see. And what's one thing that I noticed was not only the technical quality that's coming through, and of course, you know, young engineers being trained in the technical dimensions of mechanical engineering and design. That's great to see. But you could also see how the students are working together as a team, and they're approaching it as a project, and how they're allocating the different tasks. And so that kind of emphasizes, you know, not just the technical dimension of being an engineer, but the professional skills, which are all important in terms of, you know, securing a job and graduate employment. And increasingly, you know, often we'll hear from industry and companies that they want young engineers and graduates to have that technical foundation, but they also want to see those professional skills. And I think participating for the students in this kind of competition is a great way for them to build, you know, their professional skills in terms of communication, working within a project, decision making, finding solutions to problems. And so I think a competition like this is really good for that.
Excellent. And this one's going to be a bit controversial, but you've seen the level of competition here. You can see how fierce it really is. If it comes down to it, you know, in your opinion, who do you think has, you know, a really good edge, essentially, based upon design alone?
I think I may well stay neutral on this, to be honest, because I was actually impressed by the enthusiasm by all the teams that presented, and they each came up with their own solution. They spoke about them with detail, but nevertheless, you know, the solutions did have different merits and different functionalities. And I wish them, you know, well to all the teams. So yeah, maybe prefer to stay neutral at this point.
Excellent, excellent. Well, thank you very much for being interviewed, Simon. And for all of you watching at home, the races should begin around the 1 o'clock to 2 o'clock mark. Stay tuned for that, because it should be really exciting. As yesterday, some of you may have followed. Really, the suspense was leaving a lot of people speechless, essentially. So stay tuned for that, folks. Thank you very much.
efficiency degree, I want to become either a chartered engineer within the Institute of Civil Engineer industry or possibly go into project management. We have the Strength of Materials lab where we test concrete and steel. So for example, with the steel structures, we can see, like with the molar structure design, we can see how stable they can be and how much pressure they can take. So being in the lab helps us to analyze that. LSBU has supported me by offering one-to-one sessions with personal tutors, as well as the academics are arranging site visits, which can help us not only network by providing possible future internships.
distance from the wall?
Yes.
4.5. So 1.5 the barrier. From the center. And then we put it to 0.5.
From the wall.
From the wall. So that then in the what we're doing, we're moving these between the hits and the finals, so the device don't get the same length. We may move this just by 10 centimeters. So that then the target still stays relatively farther away, so we don't touch these.
Just to make a small observation, you saw that we moved this by hand.
Once
No, we moved it by hand earlier.
Oh, yeah.
Look at it.
Oh, come on. Come on. Zero. Stop it.
Spot on.
Let's check if it's parallel. Did you move it?
No.
Oh, it's gone on, is it? Yeah, it's not parallel.
I'm crowding the floor because it is what I'm going to do from the last 2 weekends. Going under my roof and running the ventilation, ducting and everything. Can you please put your hand so I can push the weight? So today they should have all the sensors, they should have not really land onto the barrier.
Yes, they all have slowed down. Now, with this target, are we sticking it or
Yes,
are we
yes,
just
yes.
putting it
Yes.
stick?
Do you need any help with drawing the line? That's great. With this right in the center.
I will use a tape measure to
Do you have another?
tape measure? All the tools.
You have a pencil to mark?
So I've been using.
How far the...
Yeah, so I've got a small one and a large one. And the large one will do the whole goal. Yeah. And because no one can't see me.
Sorry, that's
So,
right.
yeah.
The center of the tower, right? Yes. This is going to be fine. Well, I could go to the end to get to the end, but...
Well, we need to be.
But how are you going to line it? Sorry, yes.
Yeah, it has to be
How are you
very,
going
very.
to line this?
Do you want a pen or something to mark it out? I could use, but I will do it without.
Do you have Elisa string? Wait.
No.
Wait.
I can hold it.
You don't trust me.
No.
Right now, no.
How about a second tape to go down?
We have just a pencil.
Elisa string.
So
something.
Even a string. Even a...
Do we need? No, it's not.
I'm just putting them in. 610.
Okay.
205. 5 minutes. 5
Yeah, there is nothing there, so maybe. Yeah, but this we're doing Kingston A, yeah.
set the barrier once,
Yeah.
and everybody has the chance to
So
go
next
different
year,
directions.
Yeah.
That's why it's not move the barrier.
Make it easy to do. It's always been like that.
It's not the same, so.
It's always been like that. We have always for rigs, the barrier is always moved.
Second
Stays.
one. Second one, we decided it was 2.4 meter.
So we leave it 2.4.
I don't know.
Need it to be.
What is it? Was it 2.4 yesterday?
Today is 2.6. So 200. Yeah, that's trying to get the target aligned. Because we are lucky because the vehicle is hits 200 and come back. So we're going to get it. So you. Yes.
Hello, everyone. So I'm joined with Gabe and Owen. These are our LSBU students who participated last year in an IMechE Design Challenge. Thank you for being with us here today. Just a few questions. So, having participated last year and coming in the top 3, a big achievement. Congratulations for that, by the way. How does it feel being here and seeing the level of competition here as well?
Yeah, well, it's really exciting to see. Last year, it was definitely quite a tense competition. It was quite nerve-wracking going to the event. It was at Kingston University, and I think we definitely felt like one of the smaller teams there. Lots of unis went with a few different like A, B, and C teams, but I think we held our own. Our model got picked. It was like top 3 for design review, so it was really good to have it critiqued by some well-respected engineers, so we know what we can do next time. If you maybe you want to say about the design manufacturer?
Yeah, I think in the future it would have been good to have some replacement parts, or maybe not rely on so many bespoke parts and be able to maybe laser cut or have 2D manufacturing as a bigger part of the design process. But really it was more about testing and more testing after we had a physical design. I think that would have been the best improvement that we could have done.
Excellent. And in terms of having this event hosted at LSBU today, how does that make you feel as an LSBU student?
Yeah, proud. It's good to have such an involved event here at our university. Maybe one day we can recompete and learn from our mistakes last time. Definitely need to test rather than rely on what the theory says.
Excellent. And just some thoughts on the ingenuity you're seeing here today.
Yeah.
How do you feel knowing that this is seeing the level of ingenuity here, the innovation, the fact that everyone's so sort of like you can feel that spirit of competition here.
Yeah, it's exciting. Exciting to think that this is well within our realms of what we can achieve. It looks quite it looks a bit daunting at the minute because they're quite complicated designs, but it's definitely possible to achieve with enough hard work, trial and error. So yeah, it's exciting.
Excellent. Thank you very much. I suppose that's all from me here. Thank you so much for being interviewed by me.
Thank you.
We'll see you soon. Thank you very much.
Your father is from Italy, but you don't know what is it? Oh, you see, they're on the same page. I wanted the first in 2 months in my very serious. I know that we don't last more than 30 months. I actually last mindset very out. Can't say
What it is. So, if I can say so they're working whatever But then you listen to we talk about that, and then you say, that's great. But why? Talking about content case, I was not knowing one of the biggest sections of Kingston not exist. And then another one, which is Basilicata, which is originally, to be honest with you, not really is in the south, but they are very, very nice coast. Most of the region is but somebody says the companies that Basilicata
Good afternoon, ladies and gentlemen. We just got back from lunch now. The judges have just finished doing the markings on the lanes. Can everyone proceed to the lane area, please? We are about to start.
come over here, stay here for 5 seconds, 5 to 10 seconds. When they stay less, they will stay longer, they're 0.
Kingston
And then
A,
you need to move over there
can you
and
keep
stop.
your lane?
We take a picture and then run it out. So the picture is something
Can I have UCL D?
Somebody else will
Was another? Oh, okay.
UCL D, Jesus, everything is falling from my hands.
As you want.
It has to be like
So
this.
just run down over here
Otherwise
and
it's
then
upside
you
down
can
behind the camera.
check who are the winners.
No. I'm going to explain how we're going to run, yeah?
Yeah, the only issue with our design is
UCL C.
in principle, it works.
Okay, students, you have 3 minutes to set up, okay? Let me just explain, listen first. Once you're ready, you raise your hand, and I will say 3, 2, 1, go, and then you can start your devices. You have 2 minutes to do. Don't touch your device until the judges say okay after you finish the run. Okay? Right.
No, but when they go on the time, they get I can ask them to take a picture. Have I lost my phone?
Is it 3 minutes running?
Once it's on the floor, it's running.
So you guys are all set now? Okay. So not enough juice in the
Let's go.
Oh, I see. Okay. So the go button is also the power button.
Yes.
Yeah.
Yeah, when did you buy it? AliExpress, there you go.
Confident? The first
Make sure it's very straight. You see the rest of
I mean, it's looking at much.
Okay, when you're ready, raise your hands for me.
You have batteries on, right?
Happy?
You ready?
Yeah.
Turn off the laser.
Okay.
Turn off the laser.
You've got 1 minute and 10 seconds left.
Ladies and gentlemen, welcome to the race. In all lanes, you have for the short range race, you have UCL Team D, the long range is UCL Team C, and for the medium range, you have Kingston University. As they've now just placed their devices on the starting block, they can no longer touch them once, just to turn on the switches essentially. And the races have just begun, with UCL C showing a good start. Now, as we've seen in previous events, the long distance race. Any errors in the long distance race become more prominent because the distance is larger, therefore the error is more obvious. So UCL Team D has just finished there. UCL's Team C now returning back to the starting position, and Kingston University's team seems to be the slowest, but it's not always the speed that counts. Seems to be doing very well. And that is the end of the race for UCL Team C. Just... oh no. Kingston University seems to be experiencing some technical failure. We'll just have to see how that goes.
So can you not tell from your readout?
It hasn't come back, it's just hit the wall. We're just waiting to see what happens now. 30 seconds remaining. Unfortunately, Kingston University cannot touch their device at this time. So we'll just have to wait and see what the final result is. And that is the end of this section of the race. It will have to be a reset for Kingston University. And both, so essentially what's going to happen now is that there'll be a rotation of different ranges. So we're just seeing the setup for that now. So we're just swapping lanes now. As we can see, it's going to be Kingston University in the short range and UCL Team D in long range and UCL Team C in medium range. The second run for these three teams. We'll just have to wait and see what happens.
The lighting isn't preferable.
Okay, folks, we're just doing some final checks now, just before the races start. Just some small, minor adjustments, just to make sure that once the devices do come back, they're in line with the bullseye. 2 minutes left to reset. One minute remaining just before the start of this race.
Okay, get ready.
And the race has just begun. UCL Team D showing good speed coming out at the start. Kingston University again slow and steady. UCL Team C has made contact with the board, now returning back to the original position. And Kingston University has had its chance at redemption, successfully having made contact with the wall and returning back to the original position. This is great for Kingston University. An excellent opportunity to show us they can really pull through. And UCL Team C has shown that they have landed on the bullseye. Just have to wait and see the scoring. Kingston University in the short range, just going back to that bullseye. So let's just hope that they can land just on the mark. And they've landed on the bullseye, which is a very good run. Excellent, a very good turnaround for Kingston University. UCL Team C showing very good success in the medium range race. And as the races are continuing, you can really hear the suspense in the room. It's getting a lot more. There's a lot more excitement in the air. So this should be the last rotation for our teams. Rotating, if they haven't done one of the lengths of race, this will be their last chance to do that. Kingston University in the long range and UCL Team C in the short range, leaving UCL Team D in the medium range. So they should be able to do the same as they've done before, starting off at the original bullseye, making contact with the wall. Hopefully when they pass over the sensor in the beginning, it should detect the bullseye, in the beginning the sensor should detect where that landing zone should be, come back and then land ideally as close as possible to that center mark. So we're just getting ready to start that race. As you can see, again, a final adjustments being made, just making sure that the points all line up. UCL Team C just ensuring they've got that precision. Getting ready to start. And the team's ready to start. As we can see, all teams hot off the blocks, and UCL Team C has made contact with the wall. That should be returning back to its original position just before going back to that bullseye mark. And UCL Team D successful in that as well. We have seen that Kingston University has been going quite slow in all the races, but so it's always a speed, it's always about the precision in these sorts of races. Okay, so UCL Team C finishing their run. UCL Team D just shy of the bullseye mark, but nevertheless an excellent attempt. The excitement is really building up in the air. As you can hear, the voices are getting a lot more louder as the teams come to the end of this round of races. So there will be a team alternation, so different teams should be racing soon. And Kingston University, hopefully their device should be able to make those minor adjustments. Successfully made contact with the wall, now returning back to the original position.
In 2 minutes, come on.
I believe it is they have 2 minutes to complete a run from one end to the other and back.
Wait, was this what happened last time?
And it seems as though the device has recognized the colors, not returned back to the original position, but rather gone straight onto the bullseye. We'll have to wait to see what the judges think about this.
They should be able to skip that. I think the program issue is that it only goes up to a certain amount of points. So if the steps I did use long.
There may have been some coding issues with that, but nevertheless, the robot seems to have done something unexpected and still landed on the bullseye. Really unexpected stuff here. You could never expect anything when watching these races, so we'll just have to see how that goes. Nevertheless, a successful run for our teams UCL C, D, and Kingston University.
Maybe next time.
At least we finished one.
Okay, so we've got the University of Hertfordshire, both their teams A and B, just getting ready now to start at the starting block. And we've just seen the success that UCL teams C have had in their runs. So let's just hope that that form of success can be displayed across all the designs. However, nevertheless, all teams have brought that team spirit as well as that racing competition to this race. So we're just getting ready now to start off. I was told this before as well, so one of the Hertfordshire teams may have had to make some last-minute calibrations to their design due to the fact that I believe they calibrated it for an A4 piece of paper. So that should be something interesting. We hope that those calibrations are going to make a huge difference in this portion of the race. Nevertheless, suspense at an all-time high as usual.
Unsigned law.
Okay folks, so I've just heard this fresh. One of the Hertfordshire teams seems to be experiencing some technical difficulties, but both teams are approaching the starting block, so this should be a very interesting race. We'll just have to see how it goes as soon as the race begins. So stay tuned, because it should be getting a lot more suspenseful as we speak. just to remind you all, both teams have 2 minutes to set up, so we should see how that goes. Okay, both teams having their devices on the starting block. We'll just have to wait to see how it goes. Some minor adjustments being made. Just some minor adjustments being made. I believe I can see a laser inside on the screen from the Hertfordshire Team A. Just a device, just to get those fine movements made, making sure they've got that accuracy. Really an excellent level of ingenuity we're seeing from all teams this year. Two minutes left to set up. Just some last minute minor adjustments. There is a lot of activity I cannot show behind the scenes. However, I can assure you there's a lot of suspense as well as anticipation for a successful start for both the University of Hertfordshire teams. Remember folks, these are very complicated, very high intensity last minute adjustments. So remember these teams have been working on these projects for months now. And with 1 minute left, it all comes down to this. For at least this section of races, they will be allowed to recoup/recalibrate for the next section, whether that be between the long distance change or the medium distance change. So it's not over yet. Okay, so we're seeing the device for UCL Team B being put on the bullseye mark. Sorry, the University of Hertfordshire, correction on my part, apologies. We're just seeing those last minute precision makes and moves being made. And both teams seem to be ready. We're just getting ready to start. A successful start from the University of Hertfordshire, Team A. And unfortunately, I believe the University of Hertfordshire's Team B struggling to get off the block. And that's Hertfordshire back on the original mark. Going forward, back to the bullseye. They're a lot slower now. I believe for this, well, hang on a second, folks. Both teams seem to have stalled, but we'll just have to wait and see what happens. This could be due to a variety of different reasons, but we'll just have to wait and see.
Any chances? No? Shall we cut it off? Yeah? Okay.
And it seems that the judges have called it. Unfortunately, both Hertfordshire teams were having struggles with this race, but they will be allowed to recalibrate for the next round of races. Both teams switching lanes. And that's Hertfordshire Team A in the short distance. Hertfordshire Team B in the long distance. Now remember folks, with the long distance, it always seems to be that any errors are exacerbated a lot more, so we'll just have to wait and see how Team B fares in this run. And remember folks, they always have the 2 minutes to just get ready to get their devices on the starting block. Okay, folks, so we're just watching the setup for both of the Hertfordshire teams. Hertfordshire Team A on the short range, and long range Hertfordshire Team B. And there you go, Team A just calibrating, making sure that their device is exactly in line with that bullseye mark. Now with both teams unfortunately having, struggled with the first round, we'll just have to hope that there's a chance for redemption in this round.
You've got 2 minutes left.
I believe that's 1 minute left for any fine adjustments. And I believe some difficulties being seen with Team B. Or it could just be a reset, but we'll have to wait and see how that goes. And it appears that they opened up, a portion of their design just to ensure that all the wires and all the fixtures are all set properly. I've got to say, folks, the suspense is really killing me at this point. A chance at redemption. We'll just have to see how it goes. Just to remind you all, this has been months in the making for these teams. So there is a lot coming down on these races. So we'll just have to wait and see. Hertfordshire Team A adjusting once again. They seem to be ready. Team B still making those final adjustments. Let's just hope to see what happens. Just final adjustments. 10 seconds remaining. And they've closed the compartments. Just setting up now.
Okay, that's it. 3 minutes. Please. Yeah, that's it.
And the races have to start. We'll just have to wait and see.
Okay, 3, 2, 1, go.
Okay, both races starting. Team A, hot off the blocks, just scanning to make sure that their sensors have picked up the colors. They've gone back to the original block, but it seems that Team B hasn't left the starting block yet. And Team A now approaching very slowly to ensure that the device hits the bullseye. And it appears they've stopped just shy of the mark. We'll just have to wait and see. Unfortunately, with Team B, there hasn't been any movement from the original position. So this could be due to a number of reasons. We'll just have to wait and see what happens. Spirit of competition. It's really difficult. So now, unfortunately, the teams will be allowed to recalibrate and recoup for the next session of races. So their final chance at a successful run from start to finish. Remember, again, this has been months in the making, so there's a lot at stake here for both teams. Final chance. Just seeing some rotation of devices being made. So after this, it should be the judges' deliberation on who the winning teams are, followed by the grand final. Hertfordshire, Team A and B, just setting up now for that final run.
Okay, we're starting the 3 minutes now.
Starting in 3 minutes. Team B just doing some initial, I believe, calibrations, just a quick test run to ensure their device is functioning. And then now a reset.
Oh, not the mid-range. Okay, so what are you doing? Yeah, no, but what are you doing running your device?
I've just heard now, there was a practice run being done with Team B. Unfortunately, that is not allowed, but just some conflict. We'll just have a look to see what happens now. Team should be fine, but both teams on the starting block. Seems to have just been just a mistake. Both teams getting ready to set up. They do have 2 minutes to set up. So we'll just have to wait and see what the result of that is. As you can see, the crowds are all lined up, excited to see what the result of this race will be. Both teams ready.
3, 2, 1, go.
Both teams starting. Team A hot off the blocks. We'll just have to wait and see what happens. Team B, unfortunately, not just yet. Team A successfully scanning. And now returning back to their original position. So their device should have now detected how far away the bullseye is by the time it gets back to the original bullseye mark. And it seems some technical issue. Unfortunately, Team A's robot has come off the track, and now it's just battling to get back on the track. It might not be enough torque in those motors to be able to really push them back onto the track, so we'll just have to wait and see. And Team B still in the original starting position. It may have been an unsuccessful starting run for this team, but nevertheless, we've seen a lot of heart in this competition, and that's really what's mattered here.
That's the way it goes.
Unfortunately, just have to wait and see. And that seems to be all. Unfortunately, both Team A and Team B, another unsuccessful run. So now we'll just have to wait for the judges' deliberation. Just some advice being given to our teams, calculating to see what went wrong, reviewing, just making sure that they're aware that they showed a lot of heart and a lot of effort in this race. So just some words of encouragement from some judges. And that seems to be the end of the races. So we're just waiting now for some judges' deliberation. I believe there should be some announcements being made as well. Just have to wait and see. This is really exciting stuff, folks, so just don't go too far. We should have the results soon. So one thing to take from these races is, in general, with engineering, there's a lot of learning to be done. So it's with these competitions that we really do see the true spirit of engineering, the dedication, the ingenuity, what teams are willing to do to innovate, to adapt, to overcome. So I believe that's the most important thing. That's the most important thing we've learned today. So just always remember to try. And I believe yesterday we were told from one of the judges that engineers are essentially superheroes, just trying to work through and get to going through their lives, going through their stories. And this is one of those moments where the hero's in jeopardy, but we always seem to pull through, and they will do in this case. Nevertheless, an exciting round of races, so stay tuned, folks, as we should have some final decisions coming up soon.
UCL D.
Okay, folks, I'm joined with Elisa, chair of the GLR competition. Elisa, you've just seen the round of races with all 5 teams here. So what exactly is going through your mind? What's happening?
So yeah, I was there timing and helping out the judges on the lanes. It was quite tough. We had some disappointments because some of the devices were not functioning, or they were not supposed to start when they had to start. So this is part of the competition, but we recognize the team's efforts. So what's happening now? The judges, they made notes of all the scores. So they just went to the judges' briefing room to sum up all the scores and to decide what are the teams that are going to compete head-to-head into the grand final very soon.
Excellent. So, folks, we should be back soon with some results after the judges have deliberated, so don't go too far, and some really exciting results. So we should see who the winner is very soon.
UCL C. I can't see the other one. What is Kingston? Is it one of those?
Okay, we would like to call the teams for the finals now. Can we have a Kingston C, UCL C and Kingston A, please, to the lanes to compete head-to-head?
Okay, ladies and gentlemen, so for those of you who have just joined us, we've just heard this is the grand finale. Essentially what's happened is the judges have gone and deliberated. The three top teams, UCL Team C, Team C and Team D, as well as Kingston University, are racing for that grand final. Kingston University in the short range race, Team C for UCL in the medium, and Team D in the long range. Oh, my apologies. I'm just hearing now there will be two teams, UCL Team C and Kingston University. Racing for the grand final. In the grand finals, Kingston University, UCL C. So just some last minute adjustments, some precision setting for the devices. Months of preparation, preparing for this one moment. We're just seeing some adjustments being made by UCL Team C. These races have really been exciting, and so we're just seeing the results of the setup now. Just final settings. Remember, they do have 2 minutes to set up the races.
You have 1 minute left.
So the question on everyone's mind at the moment is, after having their successful runs, what could be the sources of error for the final runs? We've seen that Kingston University, with their slow but steady, yet slow and steady, we tend to know from the old moniker, slow and steady wins the race. UCL Team C, we're just going to have to see what happens. Both teams starting off. Kingston University, well off. UCL C, just going over the bullseye, scanning, successfully hitting the wall. Now we're seeing them go back to their original position. Good run thus far for UCL C. Kingston University, a lot of pressure on this one. Successfully hitting that mark and reversing back to the original position. Let's see if it will just rest on the bullseye or go back. And successful. Kingston University resetting, UCL C just trying to land back on that bullseye mark. And they've gone just a little shy of the bullseye, but nevertheless, a good score. And it's actually just reversed. Wow. You can never expect what to see at these races. So UCL C back on the bullseye. Excellent. Kingston University with 1 minute left. Slow but steady. Approaching the bullseye mark. UCL C, excellent. Excellent run. And Kingston slowly coming back to that final rest. And they've landed on the bullseye. An excellent run. Excellent coverage. So we're just waiting now for both teams. An excellent task. As you can see, applause all across the board. Excellent work, both teams, really. So this has been months in the making for both teams. And with these two teams in the final stage of this grand finale, we'll have to see which team takes it home. again, 2 more attempts for gold. They should be switching between lanes in a moment. And now rotation. Successful runs for both teams. We can only hope to see that they repeat the success they've had here in the upcoming races. So now Kingston University just setting up on the long distance, as well as UCL C setting up on the short range. Now with Kingston University, with the speed, we have seen that long range can be difficult for them, but they are, remember, nevertheless slow but steady. We'll just have to wait and see what happens. Both teams setting up. Complete silence in the crowds. A moment of high suspense for both teams. UCL C just making sure that their device is laser accurate. We'll just have to wait and see how when the races begin. Both teams ready.
3, 2, 1, go.
Both teams starting their devices, successfully moving both teams. This is an excellent start for both teams. And UCLC has made contact as well as scanning the bullseye, now just returning back to its original position. Kingston University a third of the way there. And UCLC now going towards the bullseye. And it appears they've hit the mark. Excellent run from UCLC.
Yeah, exactly. It's got the big eyes.
Kingston University, nevertheless, slow and steady, 2/3 of the length of the long range completed. Although the races are slow, there are moments of really high suspense in these races. So we're just waiting to see Kingston University's robot with 1 minute left, not having made contact with the wall just yet. They've just scanned the bullseye. So now they've made contact, a successful contact has been made, so now it's just reversing with less than a minute left to go. We're just waiting to see. Okay, and their device having stopped on the bullseye. We'll have to wait and see, and the coding has taken over. The device now stops on the bullseye, just moving forward, and it's lined up. Successful run from both Kingston University and UCLC. Excellent work. It appears with Kingston University, with the short and medium range racing, the device essentially scans the bullseye. With short, it will go back to the original position. With long, it will go back to the bullseye that it wants to go back onto, and just move a little bit forward, which is an excellent design option, because with that speed and the amount of time left, if it were to go back to the original position, it would be a problem. But we'll just have to wait and see. Kingston University, UCLC, just setting up. This is their last attempt at the grand final. Both teams showing excellent work, resilience, and ingenuity with their designs. This is a moment of high suspense. Both teams just setting up now. UCLC just making sure that their device is perfectly in line. Kingston University just giving some final looks, making sure their devices are perfectly on the mark. Both teams just getting ready to set up.
And I've generally enjoyed myself.
Minor adjustments being made.
It's really cool to see the way that UCL with the resources that they have, and the big name, how massive.
These races are always moments of high intensity. I suppose the closest I could compare this to would be perhaps a golf tournament or something, but slow, steady, but anything could go wrong, which is why your eyes are always on the prize and on the racetrack. You notice a lot of personality with these devices, some of them faster than others, some of them slower. Nevertheless, you can never know what to expect. And 1 minute remaining on setup. UCL C just making some minor adjustments, ensuring that their device is in line. Remember, they're on the long range portion of it, so any mistakes will be more apparent. Both teams showing excellent runs in their previous races. It all comes down to this. A possible failure could mean deduction of points. So high suspense. Both teams ready. We're just getting ready to start in a moment.
3, 2, 1, go.
Both teams starting. Kingston University with a successful start and UCL C with a successful start. We're seeing Kingston University doing the long range, showing excellent speed, precision, and Kingston University covering half of the race distance for the medium range race. Kingston University successfully making contact with the wall, completed scanning of the bullseye mark, now just returning back to the original position. Kingston University now just approaching the bullseye mark, so we should see it scanning, making contact with the wall, and hopefully returning. UCL C approaching the bullseye, excellent. We did see that this was an issue previously with previous teams where their device overshot the bullseye and came off the racetrack, but not the case in this situation. Again, a lot of suspense. Kingston University seems to have stopped. We'll just have to wait and see if this is a technical error or it's just a momentary glitch. And UCL C, unfortunately, Kingston University seems to have stopped dead in its tracks. And it seems exactly where the track joins up may have been the issue for that. Nevertheless, UCL C completing a successful run. We'll just have to wait and see what the judges say about this. Remember, with the scanning, these devices essentially are scanning to differentiate between colors. So any forms of differences in the track could affect the code. We'll just have to wait and see. And that seems to be all, folks. Kingston University, an unsuccessful run. Heartbreaking moments, but nevertheless, they've put in a lot of heart and effort into this. UCL C completing all runs successfully. Really was a very, very close competition. We'll just have to wait and see the judges deliberating to see who wins this. UCL C, Kingston University, or any of the other teams. We'll just have to wait and see. Really an excellent race for all. You can hear murmurs in the crowd, everyone excited. Ladies and gentlemen, just wait to see. High stress. So we should be back in a moment with more from Elisa, our chair. Just have to wait and see, folks.
But there's a skill base. Now the next line.
Oh my gosh, why now? Why now?
Annoying now. Oh my god.
It still does that.
We get
Does that first one?
Balls that straight,
It does that first one and then it's
awful man.
Does the first one and then it's
Okay, I think the second part, the second part is the last one. Like a very stupid appropriate trophy that if only we just change one version to the other.
That's actually just that's so annoying.
You know what's very nice? It's like it's ready to go off road. Yeah. The others are like sort of gazelles and they're very like yeah, it's like the lightest racer and then this is
No, but is that second part?
It's the second part. It's the time delay one. You just take that time
You need
delay.
decrease it. They would have flopped it. You need decrease it.
Okay, test it.
You need decrease the time delay.
Yeah, they just kept us here.
Yeah, but that's what we need. Why? Changes everything. Why? You don't change something that works.
That's 6 tries. No, we just do it for just go board. I think the middle one, isn't it? It's like moving. No, the pressure side.
You didn't let it. It would have gone on its own. No, that was not.
That was wind. Yes. Yellow. That's enough. It's luck. It's just luck. What was that? Yeah. It's not down there. We read it, man. I want to see what it does, isn't it?
Either way, he's going to mess up. Either way, he's going to mess up.
Bro, you got the polo on the top.
It's on his last day. Did you see that?
You gave him yours. Oh, that's so cute.
That was a condition.
Bro, I'm not gonna lie, I was about to wear it. I pulled it out there and the drink was perfect.
It's going to be black. Yeah, I don't think it might not even hit black.
Oh, that's pretty sad.
Oh, that's the first time I've done that in a long time.
That's the first time I've done that.
That's the first time I've done that.
Hey, listen, man. You deserve to win. That's the key.
You guys are really good. Alright, let's go practice thing up. In my unprofessional opinion, I think it'd be stupid to change anything.
No, you're not changing anything. 100%. Well, I'm going to keep this. You're not going to change it, bro. You're hitting 60 or 58, bro. That's enough to get you from national. No, it's enough to get you from national.
It's very, bro, but national reliable. If you've done what you did here.
Skills. Dowd, you're going to practice 10 hours.
Basically, they don't trust you.
No, we don't know the conditions. Bring banana.
Okay, ladies and gentlemen, I'm here with Elisa. Elisa, can you tell us what's going on in the judges' room right now?
Right, so they are deciding not only on the overall winner of the whole competition, but also on the other elements, such as the best poster, okay, because they're also competing on that, the best card model, the best presentation. So this is all part of this competition, and the students are really curious and really looking forward to see who is going to get the trophy today for the second day of this competition, which has been quite tough. We had very strong teams today and interesting designs once again. The finals were easy for ones and very tough for the others, as you could see, but let's see what results we are going to get.
Thank you very much, Elisa. And for now, just remain at your seats, folks, because we're just coming up with a judge's decision soon, so don't go too far. Thank you.
Thank you.
This one, the left side.
That's what I said. It's not gonna be able to read the listens of this stuff. It's not gonna be able to see. Can you move it? To the center. Deal with the let's start again.
So what was wrong? Because I pressed it and then it clicked in.
It's not doing it again. Press it again. Push it again. No, not the idea right now. It's something else. Maybe when you traveled yesterday or today, I don't know, something went off. Yeah, it's nothing shows up.
Check if the Tuesday is off. No?
No, it doesn't want to communicate. It says it's uploading.
What if that's the issue? What if you maybe that's the issue because you have all the pins from the sensors directly into Arduino and none of them is put to the ground. None of the signals. So the signal pins should be put to the ground with a 10 kilo resistor.
day for us. Late.
second year, it's the first year they have either in King's year, because the second year is less interesting. It's less interesting, it's too complicated, people in the second year, most of them in the second year. Less time to work, less experience. I think you need to better start earlier. Something about this too. It's something that unaffected in the fundamentals.
Okay. Okay, everyone, can you all take your seats? We are going to be announcing the winners of the last day of the GLR IMechE Design Challenge. Can you please take your seats? I think we have everyone here, right? I just wanted to say well done. It's been a long day. You should be very, very proud of your work. I know how hard it is to deal with a lot of deadlines. You've been through the exams period as well while you'll be doing this work, so be really proud, okay? Okay, so let's go to the part, because you might want to go and then have some food or doing anything else, right? You just don't want to be here me anymore. Okay, so the first element that I'm going to announce for today is the winners for the design review. So for third place, we have Kingston Team A. Well done. Oh, sorry, that's the wrong. Sorry, it's the wrong one. Oh. Just take a photo. Yeah. Sorry. Well done. Thank you. For the second place, we have UCL D. For the poster UCL D, you can come back because you got the third place as well, so well done. If you want another photo. Just, yeah, if you want. Huh? Okay, yeah, just forever. Okay. So which one do you want me to ask for? Okay, for presentation, we got second place UCL D. Yeah. And for peer review, UCL D. For the overall winner for the competition, we have UCL C. Yeah. Do you want to say final words? Yes, yes.
Take a photo for your website.
No, for that.
So very quick one from me. Really, really happy to see all the teams here trying to do their best in the competition, and just being here in the middle of your exams with all your products, with all the struggles that you got. It was really, really interesting. It's not normal to get 5 teams in the advanced regional. So again, thank you very much for all your effort. You should all be proud, because you achieved something that your colleagues didn't manage to get through just by being here. So again, thank you very much. I wish you all the best, and we hope that you learned something today. It is a little bit sad. So yesterday we got just 1 team going to the final, and today we got again only 1 team going to the final. But I'm afraid it's the nature of a competition. So don't be put down, and please try again in any other event, in any other stuff where you think you could learn something more for your future and for your career. So again, thank you very much. And now I believe that we have some refreshment offered by the uni. Thank you very much.
Okay, ladies and gentlemen, thank you very much for joining us for the IMechE 2024 Design Challenge. If you've been with us for the first and the second day today, thank you very much. We've just seen our champions crowned, UCL Team C. Everyone's very excited, and hopefully we'll get to see you soon next year for the IMechE Design Challenge as well. Thank you very much for joining us, and we'll see you next year.